In this video, we will be doing 8.2 practice number 1, quadratic functions in vertex form. However, for bell work, we would like to review factoring. Factoring is going to be a very big part of quadratic functions. We actually factor to find the x-intercepts. So we're going to continue practicing factoring. So when we get to factoring or solving with factoring, it's going to be almost review for you. So the greatest common factor here is -3. If you put it in slide number 1, it just says 3, but since our first term is negative, that is why our GCF is negative. So we actually have to divide out that -3. And then we create a GCF and a new trinomial. That new trinomial has a new A, a new B, and a new C. It's our simplified trinomial. So then we do A times C, which is 4, and then our B value is -5. So the only two numbers that multiply to +4 and add to -5 are -4 and -1. Now the whole reason why we did this diamond is to find these two factors, -4 and -1. You need those two because it's going to split up the x's. Now remember, we had the trinomial x squared minus 5x, and then plus 4. So this is your simplified version right here. So then we do first term, first box, last term, last box, and this -5 got split up 2 different ways. It got split up to -4x and -1x. And now we do the GCF. GCF of x squared and -4x is x. And then this would be a -1. X squared and -1x is x. And then -4x and 4 is -4. Now it does not matter which way you put it. And now the answer. The answer is actually, you have to remember this right here, this -3. You took the GCF out in step 1. And then these are now your factors. The whole reason of doing the area model is what goes into the parentheses. So that is factored form. Now today's lesson about vertex form, remember anything with the x squared, highest exponent of 2, is going to create a parabola. It's going to open upwards. We call that concave up. And then open downward, concave down. Now notice it says A is greater than 0. It's going to be positive. And A is less than 0. It's going to be open downward. It's going to be a negative parabola. So this is what we kind of did yesterday. We start at the parent function and we want to end at this vertex right here. How do we do that? We have to go left 6 and we have to go up 2. So we want to say, I'm going to erase these lines. We need to go left 6. And notice I didn't say left -6. Left implies that it's negative. And then up 2, notice I didn't say +2 because up implies 2. So left in math is negative, so -6. Up in math is a positive. And you can even just look at the vertex and tell me what ordered pair is at this vertex. This x comma y, or we're going to get used to h comma k. So this vertex is at -6 comma 2. Now what we have to do is put the vertex into the equation. Notice that it's concave up. It's facing upwards because a is greater than 0. So we know we got that correct. And then here we have g of x. So then we have a x minus h all squared plus k. So we're going to plug that in. Since it's concave up, our a value is going to be 1 for this. Eventually it's going to be a different number, but for right now it's just going to be a 1. So then we're going to have 1. Our h is -6, and our k is 2, because h comma k. So we're just going to plug that in. X minus a -6, all the way squared, plus 2. Now simplify this minus a negative. Minus a negative is adding. And then we have our y equals, or g of x equals. Honestly, either or is fine for right now. So how we can confirm that it is truly the line, let's go back up here and submit it. And then it should highlight, which it did, over the orange g of x. Now if you notice this one, we're looking at the vertex. Remember, we're going from the origin and we want to end here. Where do we end? We end at -6 comma 2. You should notice, like, oh wow, this is the same vertex that we had in the last slide. So left 6, up 2. I'm going to confirm -6 comma 2. You have to think of what's different. The only thing that's different is now it's concave down. So concave down for this is going to be, our a value is going to be -1. When your a value is any negative number, it's going to produce an upside down graph. We call that a reflection. So whenever it's a negative parabola, your a value is going to be some kind of negative. Okay, we already said our h value was -6. We already said our k value was 2. So then we just have to plug it in. Remember, minus a negative gets us that +6 inside. And then it's just going to be a +2. So y equals the -1, x plus 6 squared plus 2. Let's see. There you go. All right, for this graph, I actually took off the parent function because by now we should be just looking at the vertex. How did it move from the origin? So we're going to start here. It moved 4 to the right. And how many down did it move? It moved down 5. So I'm going to write that here. So it moved right 4. And remember, I'm not putting positive or negative because the words right mean positive, down means negative. So I'm going to check it. Positive 4, negative 5. All right, we're good. Now notice that the graph is pointing upwards. It's like a smile, so that would be concave up. And then for this problem, since it's concave up, we're going to have A equal 1. Our H is a positive 4, and our K is going to be a negative 5. So we're going to plug that in. Remember, the equation is x minus h. So x minus 4 squared, and then that's a minus 5, so we're going to minus 5. You can do plus minus, but we're trying to get away from that. Now, you know you did it correctly if it highlights over the parabola that was given. Okay, so let's look at this. We have negative 2. We had to go left 2. And then up 6. So left is negative, up is 6, positive. So I'm going to erase this. I had to go left 2 units, and up 6 units. So my vertex should be negative 2 comma 6. Notice that it's facing downward. It's like a frown, so it should be concave down. And I'm just going to write my A equals negative 1 for this because it's facing downward. My H in the vertex I said was negative 2. My K was 6. So then in the equation I'm just going to write y equals negative 1. Remember, minus a negative is really adding, so it's a plus 2 inside the parentheses. Let's confirm that we have the right graph, which we do. Okay, so this is going to be slightly different. We have this expression, and now we have to pull out the vertex. So we have the equation, and since there's no number there, we can say our A is 1. We need to do the opposite of what we see inside the parentheses. So our H is actually a positive 5. And then our K is exactly what we see. So this right here tells us our vertex. It tells us it's 5 comma 6. Now, we actually want to plot 5 comma 6. And since we know our A is 1, it's going to be pointing upward. So I just want you to draw the best U or parabola that you can. And then tell me the movement. It shifted right 5 because it's a positive 5 and up 6. Do the same. It's the opposite of what you see for positive 3, so it's going to be negative 3, negative 2. And the negative 2 stays the same. I'm going to plot that. So negative 3, negative 2. I do not see an A value. It's a positive 1 because I don't write it. So then just do your best drawing a U shape or a parabola. And then what direction did it go? Negative 3 means left 3. Negative 2 on the K means down 2. And then lastly, here's a problem. We have that negative sign on the outside of the parenthesis. The only thing that it does is reflect. It's going to be a graph that is upside down. So to find the vertex, it's the opposite of what you see inside the parenthesis. It's exactly what you see outside the parenthesis. So I'm going to draw that, negative 4, negative 2. But that negative 1 on the outside for my A value is going to reflect my graph downward. That is the only thing that is going to change here. So it shifted left 4 units and shifted down 2 units.